Ashe. My dear friends, I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic Applied Electronics Information session produced by our esteemed Elder Baba Jelani Bomani Dembe, the brilliant mind behind Majestic Mind Matters University, and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished Elder Baba Jelani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the frequency counter. Frequency counters are important tools used by applied electronics technicians to measure the frequency of electronic signals accurately. Frequency counters are designed to measure the number of oscillations or vibrations per second in an electronic signal, represented in Hz Hz. They provide technicians with a precise measurement of frequency, which is essential for troubleshooting and analyzing electronic circuits. One key aspect that applied electronics technicians need to know about frequency counters is their range and accuracy. Frequency counters are available in a wide range of frequencies, from a few hertz to several gigahertz. It is crucial for technicians to choose a frequency counter with a range that suits the specific electronic signals they are working with. Moreover, the accuracy of the frequency counter is also important, as it determines how precise the measurement will be. Technicians should consider the accuracy specifications of the frequency counter and ensure it meets their requirements for precise measurements. Another important aspect of frequency counters that technicians need to be aware of is the different types of input signals that can be measured. Frequency counters can measure various types of electronic signals, including square waves, sine waves, pulse signals, and more. It is essential for technicians to select a frequency counter that can accurately measure the specific type of signal they are working with. Some frequency counters may also offer additional features, such as the ability to measure duty cycle, period, or totalize counts, which can be beneficial for certain applications. Calibration and calibration procedures are also crucial for applied electronics technicians when using frequency counters. Calibration ensures that the frequency counter is providing accurate measurements and is functioning correctly. Technicians should follow the manufacturer's instructions for calibration procedures and perform regular calibrations to maintain the accuracy of the frequency counter. It is recommended to use a frequency counter with a built-in calibration feature or to have it calibrated by a professional calibration service to ensure accurate measurements. Furthermore, applied electronics technicians should be familiar with the various input and output options available on frequency counters. Some frequency counters may have multiple input channels, allowing technicians to measure multiple signals simultaneously. Others may offer additional input options, such as external trigger inputs or frequency reference inputs. Understanding the input and output options of a frequency counter can help technicians choose the most suitable device for their specific applications and requirements. In addition to basic frequency measurement capabilities, some frequency counters may also offer advanced features that can be beneficial for applied electronics technicians. These features may include digital signal processing, statistical analysis, waveform display, and data logging capabilities. Advanced features can enhance the functionality of a frequency counter and provide technicians with more in-depth insights into the characteristics of the electronic signals they are measuring. Lastly, it is important for technicians to consider the portability and durability of frequency counters when selecting a device for their applications. Portability is essential for technicians who need to measure frequency signals in various locations or environments. A compact and lightweight frequency counter can be easily transported and used in different settings. Additionally, durability is important to ensure that the frequency counter can withstand the rigors of daily use and maintain its accuracy over time. Frequency counters are essential tools for applied electronics technicians to measure the frequency of electronic signals accurately. Technicians should be familiar with the range and accuracy of frequency counters, the types of input signals that can be measured, calibration procedures, input and output options, advanced features, and portability and durability considerations when selecting a frequency counter for their applications. By understanding these key aspects, technicians can effectively use frequency counters to troubleshoot and analyze electronic circuits with precision and efficiency. Applied electronics technicians rely on various tools and equipment to ensure the proper functioning of electronic devices and systems. One such tool that is commonly used by technicians is the frequency counter. A frequency counter is a device used to measure the frequency of an electronic signal, typically in Hertz, Hz, or kilohertz. Frequency counters are essential for testing and troubleshooting electronic circuits, as they provide valuable information about the frequency characteristics of a signal. When using a frequency counter, it is important for technicians to be aware of certain factors that can affect the accuracy of their measurements. By following best practices and guidelines, technicians can ensure that they obtain reliable and precise frequency readings. In this essay, we will explore what applied electronics technicians need to know about frequency counters in order to use them effectively in their work. The first step when using a frequency counter is to check all connections and cables to ensure that they are securely connected and not damaged. Loose or damaged connections can lead to poor signal quality and inaccurate readings. By ensuring that all connections are tight and properly maintained, technicians can eliminate potential sources of error in their measurements. Next, technicians should use a known reference signal to verify the accuracy of the frequency counter. This can be done by connecting a signal generator or any other known frequency source to the frequency counter and comparing the reading with the expected frequency. If there is a discrepancy between the two readings, adjustments may need to be made to the frequency counter settings or calibration. It is also important to verify that the input signal is within the frequency range and amplitude limits of the frequency counter. Signals outside of these limits can cause the frequency counter to provide inaccurate readings. By ensuring that the input signal falls within the specified parameters, technicians can obtain reliable measurements from the frequency counter. Technicians should also check the settings and configurations of the frequency counter to ensure that the proper measurement parameters are selected. Incorrect settings can lead to inaccurate measurements and misinterpretation of data. By double-checking the settings before taking measurements, technicians can avoid potential errors and ensure the reliability of their results. If the frequency counter continues to provide inaccurate readings after troubleshooting, technicians may consider following any calibration procedures provided by the manufacturer. Calibration procedures may involve adjusting internal settings or using external calibration equipment to ensure the accuracy of the frequency counter. By following these procedures carefully, technicians can calibrate the device and improve the accuracy of their measurements. In some cases, if the frequency counter still does not provide accurate readings, technicians may need to contact the manufacturer for further support or send the device for professional calibration and repair. Manufacturers may have additional resources and expertise to troubleshoot and resolve issues with the frequency counter, ensuring that it functions properly for future use. Lastly, technicians should keep the frequency counter clean and well-maintained to ensure accurate measurements. Dust, dirt, and other contaminants can affect the performance of the device and lead to inaccurate readings. By regularly cleaning and maintaining the frequency counter, technicians can prolong its lifespan and maintain its accuracy over time. Frequency counters are valuable tools for applied electronics technicians, providing essential information about the frequency characteristics of electronic signals. By following best practices and guidelines, technicians can ensure the accuracy and reliability of their measurements using frequency counters. By checking connections, verifying reference signals, confirming input signal parameters, adjusting settings, calibrating the device, seeking manufacturer support if needed, and maintaining the device, technicians can effectively use frequency counters in their work. With proper care and attention to detail, technicians can rely on frequency counters to support their electronic testing and troubleshooting needs. Frequency counters are essential tools for applied electronics technicians as they provide a convenient and accurate means of measuring the frequency of electronic signals. However, the usefulness of frequency counters extends far beyond basic frequency measurement. This essay will explore some of the more advanced applications of frequency counters and what technicians need to know about them in order to effectively utilize them in their work. One important application of frequency counters is in phase-locked loop, PLL, frequency synthesis. PLL circuits are commonly used in communication systems, radar systems, and clock generation to lock onto and generate specific frequency signals. Frequency counters play a crucial role in tuning and adjusting the PLL to achieve the desired frequencies. Technicians need to understand how frequency counters interact with PLL circuits and how to interpret the measurements taken by the frequency counter to ensure proper operation of the system. Another advanced application of frequency counters is in frequency hopping spread spectrum techniques. In wireless communication systems, frequency hopping helps improve signal security and reduce interference by rapidly changing the frequency of the transmitted signal. Frequency counters are used to implement and monitor the frequency hopping patterns, allowing technicians to ensure proper synchronization and operation of the system. Technicians must understand how to program and control the frequency hopping sequences using the frequency counter to achieve the desired communication performance. Frequency counters can also be used in signal analysis and characterization. By combining a frequency counter with other test equipment, such as spectrum analyzers or oscilloscopes, technicians can analyze and characterize complex signals, such as modulated signals or noise signals. This advanced application allows technicians to gain valuable insights into the behavior of electronic circuits and devices, helping them troubleshoot and optimize system performance. Technicians need to be familiar with the various measurement techniques and analysis tools available for signal characterization using frequency counters. In addition, frequency counters play a key role in the calibration and testing of electronic components. By measuring the frequency response and accuracy of components such as filters, oscillators, and sensors, technicians can ensure that these components meet the required specifications for a given application. Frequency counters are used to verify the performance of these components under different operating conditions and environmental factors. Understanding how to use frequency counters for component testing and calibration is essential for maintaining the quality and reliability of electronic systems. Furthermore, frequency counters are used in precision timing and frequency standards, such as atomic clocks. These standards provide highly accurate references for timekeeping and frequency synchronization in various applications, including telecommunications, navigation, and scientific research. Frequency counters are used to monitor and maintain the stability and accuracy of these standards, ensuring consistent and reliable performance over time. Technicians must understand the principles of time and frequency standards and how frequency counters are used to measure and control their outputs. In conclusion, frequency counters are versatile tools that play a critical role in a wide range of advanced electronics applications beyond basic frequency measurement. Applied electronics technicians need to be knowledgeable about the various advanced applications of frequency counters, including PLL frequency synthesis, frequency hopping spread spectrum, signal analysis, component testing, and time and frequency standards. By mastering these applications and understanding how to effectively utilize frequency counters in their work, technicians can ensure the accurate and reliable operation of electronic systems in various industries and applications. Thanks for your participation in this special Majestic Mind Matters University Basic Applied Electronics Information session. I am your royal narrator, Queen Magical Melanin. Here is a special message from our esteemed Elder Baba Jelani Bamani Dambe, the brilliant mind behind Majestic Mind Matters University. To all applied electronic technicians, he wants you to know this. Your participation with Majestic Mind Matters University has been invaluable. Your expertise and commitment to excellence has elevated our research and knowledge in the field of applied electronics. Thank you for choosing Majestic Mind Matters University as a trusted source for your valuable applied electronics information to aid to your success with this basic applied electronics information session titled Introduction to the Frequency Counter. Stay woke. Ashe.